приветствовать вас сегодня в Одессе. Если вы приехали из других городов, и ребята, которые пришли из Одессы, тоже все очень рады. Сегодня у нас пройдет, наверное, первая самая масштабная конференция за несколько последних лет по Java в Одессе, Java Breeze. Немножко предыстории. Мы год назад, 21 мая, запустили о логике встречи форума одесских Java-специалистов. На протяжении года многие из вас были у нас в гостях, посещали мероприятия, которые проходили в разном формате. Это были и презентации с докладами, и тренинги, игровые соревнования. Вот сегодня мы решили 10-ю юбилейную встречу провести в рамках конференции. Сегодня у нас будет много интересных спикеров. Спасибо большое всем, кто приехал не только из Одессы, вот, с разных городов. 2 потока докладов, у всех есть программки, поэтому будет много чего интересного. Вот. Я хочу сейчас представить нашего первого спикера, который приехал из Швейцарии, из Цюриха. Нам очень приятно, мы очень удивились, но очень приятно обрадовались. Вот. Сэм Brannen, он очень известный спикер в рамках спринга на европейской конференции из Штатов. Сегодня он у нас. Будет 2 презентации. С первой презентацией он выступает уже сейчас. Все вопросы, какие-то, не знаю, там, дискуссии вы сможете вести с ним в перерывах. Вот, я передаю слово Сэму, приветствуйте ее. Презентация будет на английском. Вот, всем хорошего дня.
Can you hear me? Is it good? Yeah. So I have no idea what you just said. I hope it was all nice stuff. First and foremost, thank you for letting me come here to talk to you today. It's an honor. I've never been to Odessa, so maybe I get to see a little more tonight. I saw it a little bit last night and enjoyed seeing the conference with you guys. Start off here. The topic of today is composable software architecture. Maybe something you're familiar with already doing, maybe something new, and also with a look at how Spring makes it possible to have a composable software architecture. So this is rather high level, kind of somewhat academic, but hopefully it gives you some inspiration to how you can organize and design your own projects. And then some of the rest of the talks later in the day will help you see how to do things in the real world, hands-on. So, since I don't know what she said about me, I'll tell you a little bit about myself. My name is Sam Brannen, and I am American, as you might tell from my accent, although I do live in Zurich, Switzerland currently. I work at a company called SwiftMind, which I founded in 2010 with some colleagues of mine, and we are Spring and Java experts, and I'm also been developing Java for over 15 years, which is quite some time for Java developers, and I am a core committer for the Spring framework. That's probably the main reason I'm here today, and I've been doing that since 2007. I'm basically in charge of the Spring testing support, so the test module, the Spring test context framework, if you're familiar with that. And I'm also a Spring trainer and a presenter on topics such as Spring testing, Java, and OSGI. Yeah, so my company, I mentioned SwiftMind, we're experts on enterprise Java, focusing primarily on the Spring framework for myself, the Java EE in general, as well as OSGI, Agile, Scrum, best practices in software engineering, etc. We're in Zurich, and here's some information if you want to check us out on Twitter or the web page. So first up on the agenda, we'll take a few minutes to talk about what enterprise applications are. What does it mean to be an enterprise application? Then we'll talk about what we've learned as a community based on experiences over the past years in the Java community. Then we'll take a look at what a composable software architecture is, what it means, what it could look like. Talk a little bit about Java EU plus open source, including Spring, and then specifically about how some of the Spring portfolio projects make it possible for you to have a composable software architecture. And last but not least, if there's time and interest at the end, we can talk a bit about some of the Spring 4.0 roadmap, which will be coming out later in this year. But first, just a show of hands. So I guess everyone is a Java developer, is that correct? Yes? All right. Who has used Spring before? Okay, good. And would you all say you're Java EE developers, so enterprise developers, mainly? Okay, so it's the right target audience. All right, so we'll start off with modern enterprise applications. What does enterprise mean? So I've pulled off some definitions here from Wikipedia, which is our favorite resource on the web for all information, even IT related. Yeah, so if you scan through this, what does enterprise mean? It means some kind of software used in organizations, big business, big government, typically software not used by an individual, so it's not like a desktop application. So yeah, that's all well and good, what does that mean to us as developers? If you read a bit further, you'll see there's a notion about enterprise software typically has interfaces to other enterprise services and software and is centrally managed. So this is now actually starting to say something to us as developers. Now we're getting somewhere. So then what would I say is a typical enterprise application? What are some of the aspects? First off, you're supporting some kind of enterprise business processes, so big processes, not just small little standalone applications. Code's going to be relatively large code base, but you also want to have your application be robust, scalable, and offer high performance, of course. And these things don't happen in isolation, so you're not just going to have a small little application running by itself. Typically, you want to interact with multiple external systems and services. So for example, you have to access a database, store some data, read some data, maybe pulling user credentials from LDAP, maybe sending emails via SMTP, working with files remotely, FTP, SSH, etc. We also might have some needs for some queuing or some messaging, so you have JMS and AMQP as protocols and APIs. Web services, you might have to invoke some SOAP-based web services or RESTful web services, or you may have to expose your own. And going along those lines in terms of exposing content, you're probably going to be exposing content either as for web clients such as browsers or mobile clients, etc. So these are kinds of the things that define what an enterprise application is these days, the kind of things you deal with on a day-to-day basis at a high level without looking at the actual technologies used. So, but each of these individual technologies has its own APIs and potentially different protocols and exchange formats. So you might be going over HTTP, you might be going over SMTP, you might have different third-party libraries you have to use, you might have different enterprise Java EE APIs you have to use, and you might have different formats. You might have something like XML or JSON, etc., or some kind of custom proprietary format. And these are things you have to keep in mind when you're designing your application, because you want your application to focus on your business logic and your internal domain model, and then kind of extract and shield your internal application from these external details. So, keeping all this in mind, how should we design such enterprise applications? So we'll take a look at what we've learned as a community. Over the years, some of the do's and don'ts. First off, what should we avoid? What have we learned to avoid? So hopefully everyone knows we should avoid tight coupling to the container itself. So you don't want to be tied tightly to the Java EE container. You also don't want to be tied tightly to the framework. So in the past, you would extend, for example, particular classes from a framework or from the container, or you would implement interfaces from that framework or container. And these days, that's something we don't want to do. We also want to avoid tight coupling to protocols and exchange formats within our service layer. So we want our service layer to be pure, working with our business logic, with our domain. And then we want to build what we call basically a protective layer that shields us from changes to outside protocols, etc. We'd also like to avoid monolithic deployment units, so really big bang deployment units, all the code and maybe in one project, and maybe even everything loaded up in one WAR file or one big year file in Java EE. And we'd like to avoid anemic domain models. Who knows what an anemic domain model is? Is that a familiar term? 3 or 4 people? Okay. So anemic domain model is the idea that even though we're using Java and Java is object-oriented, we want to do it kind of procedurally. So we have objects that just hold a little bit of data, don't have any actual behavior. So we've actually separated our data from our behavior, and that's an anemic domain model. So one ideal with object-oriented programming is to co-locate your data and your behavior. So that's something we'd like to avoid, is this notion of anemic domain models. And if you've heard of domain-driven design, that's an attempt to address this kind of issue. We also want to oftentimes avoid bloated transaction scripts. So in other words, having a lot of procedural code in our service layer instead of moving the data out to particular objects, we focus on a more fine-grained functionality. And last but not least, some concepts from AOP. Who's familiar with AOP, Object-Oriented Programming? You good? All right. So some of the 2 main concepts here that we want to tackle with things like AOP is avoiding code tangling or scattering. So code tangling is where you have multiple concerns mixed in the same code base. And in the past, you basically kind of had to do that. But when I say in the past, I mean many, many years ago, with things like AOP, aspect-oriented programming, you can pull code out and reuse it, and also code scouring, where you have the same code used multiple places in the code base with copy-paste. So these are the kinds of things we want to avoid, but in the past were rather common in Java applications. So, with that in mind, what should we actually aim for? What should our goals be? Of course, we should aim to be modular, not just within our code, within our project, but also across our projects. In other words, have multiple projects, maybe not too fine-grained, but fine-grained enough where we're focusing probably like on the user aspect or the payment aspect, where we can have different teams or different groups of developers working on that code. And we want to have a layered architecture. Also, nothing new particularly, but what I'm going to talk about here a bit more is the notion of a canonical domain model. We want to have one central domain model used across all of our modules, and we want to have a dedicated orchestration layer. And I'll get more to that in a few minutes. Of course, we want to promote separation of concerns, so not mixing things like security and transaction management within our business logic, but actually focusing just on business logic within our code. And we want to, where possible, externalize our configuration and also environment-specific configuration. So you might be deploying these days, when we talk about enterprise these days, it's not just to Tomcat, maybe you're deploying to Tomcat, maybe to Jetty, maybe to Java EE, and within the ear, maybe deploying to the cloud. So you have some different deployment environments that you want to deploy your code into, and you'd like to externalize the configuration for that. And you should also design for testability. So it's kind of the notion of TDD, just coming in, test-driven design. If your code's not easily testable, then it's also probably not very well designed or very modular. And also not very composable, as we'll get to. So how can we achieve these things? What kind of tools do we have to work with? Some of them very old, right? Academic, object-oriented analysis, design, and programming. We use these tools, but if we use them right, we end up with what we call a POJO programming model. Hopefully everyone's familiar with that. So plain old Java object, and I have here this at in front. So an at POJO model is kind of an extension. You've been able to use POJO programming models for years, and then with Java 5 we got annotations in Java, so that really opened up a whole slew of functionality and new features in multiple frameworks. So you think about Hibernate annotations, JPA entity mappings, stuff like that, JSON annotation mapping in Spring, etc. So many of the frameworks are using this. It allows us to basically remove the dependencies in terms of class hierarchies and interface implementation within our own code that we write. Another very nice set of tools is the kind of the combination of marshalling. So to and from different types of external formats. Maybe it's a JSON or XML into your domain entities, and also automatic type conversion. So having types automatically converted for you by your framework. This allows us to decouple our code from external formats, etc. Dependency injection, also hopefully nothing new to you, but also plays in well with the POJO programming model, allowing us to program interfaces, swap out stuff, and have things like an orchestration there. Inversion of control also plays into that, and as I mentioned before, so AOP or an interceptor type model allows us to do that. Last but not least, automated out-of-container testing and CI allow us to have faster development test cycles and ensure that we have regression testing in place for refactoring. So that's it for the background for what we've learned, where we want to go to. Now let's talk a bit more in detail about what it means to have a composable software architecture. Again, if we turn to Wikipedia or some other source, you might find a definition like this. So composable software architecture is related to composability. Composability is basically a system design principle dealing with interrelationships between your components, and a composable system should provide recombinant components, as it says here. They can be selected and assembled in various combinations. So recombinant means we can recombine them in different ways, take existing stuff that we already have, and a few points down at the bottom, each part should be self-contained, so modular, for example, so its own Maven project. Maybe you can build it, test it on its own, and these components will be typically stateless, though not required to be stateless. So, but it's not just about modularity and statelessness. It's really a different way of thinking, if you're not used to this way of thinking, and a different way of designing your application. Resulting in basically a different kind architecture in terms of how things are actually implemented and tied together at runtime. So this provides us lots of new possibilities with some of the new modern frameworks if we do it right. So I'll talk a bit about how we can hopefully achieve that and do it right. What we basically want to do is we want to think about different ways that the existing components we have, so maybe our user services, our payment services, stuff like that within our service layer, how can we reuse those in the application? Perhaps potentially repurposing them, using them in a different way, the way that wasn't previously foreseen, and compose them in a different way. So we want to do this to meet different business requirements as they come in, as needs change over time, or perhaps to interact with different systems. Maybe we provide the same data now in a new way. Maybe in the past we just had a web page displaying it, and now we want to export it or somehow provide it as a JSON format for a mobile client, or maybe provide it as an XML output from a web service. But at the same time, reusing the code that we already have and writing as little code as possible and having to retest as little as possible. So here we have basically a visualization of the composable architecture. Starting on the left, we have the domain model. Again, this is the canonical domain model we're using across our application. Then we have things like infrastructure, so security, transaction management, data source, connection pooling, etc. On top of that, a repository layer. So this is the data access layer, communicating with layers below, service layer. So at this point, you're probably saying that's exactly what I already have in my application. Hopefully you have something similar to that. And then on top, what I'm showing here is what I call the orchestration layer. So that's kind of the new part, or the part I want you to focus on here. You might be asking yourself, how is this new? This is pretty much in every textbook. So to be honest, it's really not new if you're just looking at the diagram like that. If we took that diagram and compared it to other diagrams you've seen, then you would say that top part in green that was orchestration, well, that's really just equivalent to the web tier or presentation layer that I currently have with JSP or JSF or something like that. So, but the difference is, what I want to point out here, the difference is we want to reuse all of the existing layers. So all of the canonical domain model we had, the service layer, repository layer, infrastructure, all that configuration, we want to reuse that, not modify that, and add different types of orchestration on top of that. For the orchestration layer, it lies basically at the heart of this notion of a composable architecture. And it will orchestrate all of the interactions with your service layer, so with your existing service layer, or potentially new service methods you add to it, and potentially interacting directly with repositories in the case of something like batch processing where you don't need to go through the service layer. One very important point is that the orchestration layer is responsible for handling interaction with all external protocols. So the orchestration layer should know about the external protocols, whether it's SMTP, or whether it's FTP, or whether it's HTTP or something like this, and your service layer should just focus on your business logic. Building on that, the orchestration layer is also responsible for converting from the external formats into our canonical domain model. So the domain model we saw on the left in blue, we don't want to know about something specific to a JSON document or something specific to an XML SOAP request document within our service layer. We want to focus just on our plain Java domain objects. So basically, by having this allows us to combine our application components in different ways and implement new features on top of it. So some common types of orchestration. First and foremost, the web tier. So you probably have a web controller dealing with on terms of protocols, HTTP, HTTPS, built into your server container, so that's part of Java EE. And then the formats, so you're basically processing an HTTP request or response, and then returning a response, dealing with request queries, etc. And then in terms of web services, we have both REST and SOAP. So HTTP, HTTPS is the protocols coming in for REST, and then dealing with formats like XML documents, JSON documents, perhaps binary payloads, etc. And you want to have that handled by your web service endpoint and then converted into your domain model for internal processing in your service layer. Messaging, you have things like JMS and AMQP. converting from JMS types, for example, into domain entities, automatic type conversion or automatic marshalling. And in terms of messaging, we talk about enterprise application integration patterns. We have things like messaging endpoints. So, for example, an inbound gateway coupled with a service activator and processing things externally like web services, FTP, file system, email, etc., but hiding the details of that from our service layer. So we still configure our access to the FTP server or to the email server, but then once we get into our service layer, we're just going to work with our canonical domain model. Who's familiar with enterprise application integration patterns? Few people? Who's heard of Spring integration? Or Apache Camel, stuff like that? Few people? Okay. Last but not least, also batch components. That would be another typical type of orchestration layer, where you have your service layer or your repository layer. Batch is one example or one exception to the rule, where you might not be going through the service layer, but rather directly through your data access layer, because the batch processing layer, or the batch framework, should know how to start and basically manage your transactions, chunk sizing, etc., for your readers, writers, and processors. And that works with things like flat files, CSV files, SQL, etc. So these are all the typical types of orchestration that you would have built on top of your existing layered architecture. Now, in terms of Java plus open source, just a quick overview of what's good about Java EE, what we like about it. Of course, there's lots of good things, just a few points here. So common enterprise APIs, right? So an implementation, so you can reuse the same configuration and code across containers if you want to deploy to different containers. You also have great tooling and build support, obviously, these days. And over the years, we've learned on our own as a community, and also Java community process and Java EE has learned to basically benefit from some of the innovation in open source. So two main things I like to put on here: think about Hibernate, really pioneered object relational mapping, right? And that became a standard as JPA. And then things with like dependency injection and version control, really promoted by frameworks like Spring, Juice, and Seam, ended up being CDI standard in Java EE. So Java EE is definitely getting better over the years. It's a one-stop shop, and that's great if that's everything you need is in that one particular shop. But if it's not, doesn't have everything you need, then basically what you have to do is use open source frameworks to either within Java EE container or in an alternative lightweight container. Maybe you're running just in a Tomcat or just in Jetty or some other container coming up in the future that hasn't yet been developed. So the point here is that we use open source frameworks to fill the gaps in various scenarios. Many of these focusing on, or at least applicable when we're talking about having composable architecture, adding new functionality on top of an existing application, adding functionality that we can't potentially get out of standard Java EE. So reasons you might move to open source, pull into open source, so you want to use a different kind of web framework, some additional UI components that are available within Java EE. If you have needs like NoSQL, graph databases, etc. If you're working with big data, AMQP instead of JMS, so but another type of messaging here, and brokers. Maybe you're using writing mobile applications for iPhone and Android, not part of Java EE, but you still have needs for that. You have clients that use that. Social media, batch processing, enterprise integration, these kinds of things that you don't get with Java EE, you can look to open source for that. And then the list goes on from there. So now, we'll talk about how Spring fits into this picture, how we can use Spring as open source with Java EE, adding on to what we have with Java and Java EE, and achieve a composable software architecture. I've written here core Spring framework. So when people hear Spring, they oftentimes think just Spring framework. And so here I've said, well, Spring framework is the actual name of the core project, right? It's been around for many years, but it's also an ecosystem. We'll talk about that in a minute. But focusing now just on the core. So what are the features we get from Spring that we've always gotten from Spring that enable us to write nice modular applications? First up, we add dependency injection, inversion of control, and AOP. And things like declarative transactions, caching, validation, and formatting. So this, all this declarative stuff means that we're not handling the transactions or the caching security set within our service layer, but externalizing that either via annotations, NOT, or perhaps in XML configuration. But that allows us to basically reuse or recompose those services the way we need to. Also within core Spring, we have the web frameworks of Spring MVC and Spring MVC REST, which also play into this notion of composable architecture, where you can reuse the same service layer with web applications, with RESTful applications, with other types, as we'll see in a minute. Also within core, there's a really good support for JMS, in the form of the JMS message listener container. Who's ever heard of the Spring message listener container? JMS? Who's ever used JMS? Okay, so not so many. Right, so this is the notion of message-driven POJOs. That's in stark contrast to message-driven beans that we get from EJB. And message-driven POJO obviously follows the POJO program model, allowing you to not be tied to the JMS APIs. And of course, we also have the testing framework that allows us to basically test our composable architecture with our production-like configuration. So, dependency injection and inversion control, we take them together. They collectively decouple the application from the deployment environment. And so if we look at dependency injection plus inversion control, that brings us to, or enables, a POJO programming model. So again, POJOs, where we're not depending on the framework, we're not depending on the container. Now if we take that a step further, so we take this POJO program model, so our POJO services, domain entities, etc., and then add new functionality like transaction management, security, caching, etc., with AOP, so attribute-oriented programming, that enables composability, so it allows us to reuse these components or this model in different ways. As I mentioned before, Spring is an ecosystem, so Spring is a generic term. Spring Framework is the core, but built on top of that, we have many other sister projects, so to speak. Spring MVC and REST are within Spring Core. And then we have other frameworks like Webflow, security. For SOAP web services, we have a separate project. For batch processing and enterprise integration, we have Spring Batch and Spring Integration. The list goes on and on. If you want to check out the website, I have a link later on. But now let's take a look at a few of these and how they use some of these notions of inversion control, potentially AOP, automatic type conversion, etc., in order to reuse your service layer and provide additional functionality on top of that. So basically allowing you to achieve a composable software architecture. First up, we have Spring MVC and REST, basically combined together. So if we were to look in the code, we would see that in Spring MVC and REST, each of our components are controller classes, so just annotated POJOs, annotated with that controller. They're not implementing any interface or extending any classes from Spring. And the methods within those controller classes, these handler methods, and they serve as, the annotated methods within this class serve as the handler methods, so the code is invoked for Spring MVC, and in the case of REST endpoints, they serve as the RESTful endpoint handling methods. And for those, the framework itself, Spring provides automatic type conversion, so from input types from your HTTP request, for example, into methods to your method arguments and domain types. There's also data binding, so directly binding from the request parameters onto your domain model. It's also called, for example, a command object or form backing object. And then we also have this notion of marshalling, which I mentioned before. So marshalling was used less, or is used less, when you're talking about just straight up web applications. But when you start talking about applications like RESTful web applications, then you have different types of formats that you support. So different types of things or content types that you accept. You might accept JSON as a content type. You might accept XML as a content type. And for that, there's support for basically JSON marshalling, so with the Jackson mapping API, if you've ever heard of that. And then Spring supports several different OXM, so Object XML mapping technologies such as JAXB 1 and 2, Castor, XML Beans, etc. And then in terms of composable architecture, these so-called handler methods and RESTful endpoints, these are the points in your code that are actually orchestrating the service layer. So in the past, of course, you have this tiered architecture, web layer, service layer, data access layer. But if you think about it like this, what I'm talking about here with orchestration, then these handling methods and endpoints actually become part of our orchestration layer. Comparing that with Spring Web Services, if you look at the code between, for example, Spring MVC RESTful web applications and Spring Web Services SOAP-based web applications, if you actually looked at one of those classes, so an MVC controller or a Spring Web Services endpoint class, the code looks almost exactly the same if you can kind of put on your anti-annotation goggles, so looking straight at the code and maybe deleting all the annotations. The methods would almost be the same. The method signatures would almost be the same. Taking in, for example, a domain or a request object and returning a response object for a particular use case. I also have a presentation on that on SlideShare if you want a comparison for that. But if you look back at the previous slide, you see we started with @controller. Here we have @endpoint. So @endpoint is an annotation specific to the Spring Web Services project. Basically, you can annotate one of your classes with that, and it says, this is a SOAP web service endpoint, and then you have particular methods within that actually serve as the actual processing endpoints. And like we had with Spring REST, you're also going to use marshalling, so to convert from an external format, so in this case with SOAP XML, into your domain model, for example, or perhaps into an auto-generated set of types from JAXB based on your schema. And again, you can use OXM, so this object XML mapping support within Spring to convert from that XML request into an object in your code base. Work with that object internally, invoke your service layer, and then return an object again and have that automatically converted into XML with the OX mapper. So like we had on the previous slide with Spring MVC, so with the controller, with Spring Web Services, we have an endpoint, and the endpoint methods are actually performing the orchestration with your service layer. But it's a combination of the code you write in your endpoint and the support provided by the framework. So internally, you are actually orchestrating the service layer, and the framework is handling things like the protocol and the external format via marshalling. Next up, Spring JMS. So this is the in-Spring core, the very key part here for messaging. We have what I mentioned before is a message listener container implementations in Spring. There's also XML namespace support for that. And it allows you to, one, work with the JMS message listener API if you want to implement that, or if you have some existing code. But going beyond that, as I mentioned before, provide support for message-driven POJOs. So this is what we're talking about with the POJO program model, allowing you to reuse and recombine your service components in different ways. And to work with that, or to enable that, Spring performs automatic type conversion for you. So for your POJO is probably going to work with an object from your domain model, or maybe with a string, representation of a document, for example. And out of the box, Spring will perform automatic type conversion from JMS message types into strings, maps, objects, binaries, etc. for binary data. But you can also provide your own converters. And again, you can use marshalling. So if you wanted to define the payload of your messaging or your messages as XML documents, you could have a schema for that and have it automatically converted into your domain model, coming into your service layer, and then via message-driven POJOs, have Spring's message listener container basically invoke your service layer. Then you have a response coming back from that, and Spring will automatically convert that as well, and then send it back as a response if there's a response for this or reply queue. So in this sense, your service layer is just your service layer. It's not doing anything special. It doesn't even know that it's being invoked in the context of JMS. It just takes your domain model, an object from your domain model as an input, and gives an object from your domain model as output. And the message listener container from Spring is actually performing the orchestration of your service layer. So you've externalized this into your Spring configuration. Spring integration, building on that and enterprise integration patterns. So here we have things like inbound and outbound messaging gateways coming in. These are responsible for handling the external protocols and knowing about those APIs. There are way too many basically adapters and gateways here to mention. You can check out the reference manual and the website for more details on that. But what I'd like to put out here is that you get automatic type conversion as well for method arguments and return types for service activators. So service activator is basically a way in configuration to say something is coming in on this channel, so this input pipe, and I want to have the payload, whatever that information is, automatically somehow passed off to a method in my service layer. And this is the notion of a service activator. So you basically say, here's my service object, here's my service method, please invoke this method and perform some kind of type conversion, passing it in as an argument, and then if my method returns a result, just like we saw with JMS the previous page, then that would be converted and passed on to the reply channel, just like we saw with JMS as well. So here we have, again, the notion of marshalling and custom type conversion, allowing you to support these different kinds of protocols and formats externally, but in your service layer to just focus on your domain objects, or your canonical domain model. And your service layer can be converted, on the one hand, via annotations if you want to go that route, but also declaratively and externalized in your XML configuration with the XML namespaces from Spring Integration. So the list goes on. I could go through some of those other projects that I listed in the Spring portfolio and show you how they also enable this composable architecture. But I invite you to check out the reference manual or ask me questions later on if you have particular interest in that regard. But let's take a look now back at the picture we had before. Again, the domain model, canonical domain model on the left, used across all the layers, across all the modules. The same infrastructure, same repository, same service layer. And on top of that now, for orchestration, we could add in different types of orchestration. So starting off, we might add in Spring REST. We might later add Spring MVC supporting web applications, standard controllers, adding in Spring JMS. So maybe we're just gradually building up functionality of our application, or maybe this is happening over time as we get new requests, new business needs to interact with different types of systems, or to provide information in different ways. So we could also add in stuff now we need support for SOAP web services, batch processing, Spring integration, et cetera, et cetera. The point is that you haven't changed anything, or hopefully not much of anything, in your service, repository, and infrastructure layers. The domain model you can keep reusing, gradually evolving over time, and then just add in different types of orchestration technologies. Again, I've listed Spring projects here as an example, but you could, for example, use something like Apache Camel for your integration, or some kind of other Java web frameworks instead of Spring MVC, etc. So the main point here is that you have a consistent service layer, Kojo program model, and that you use different types of frameworks on top to orchestrate your service layer. Which brings us to the basic checklist. So we want to start off, again, make sure that we've modularized our code, not just within our Java packages in one project, but across our project, across our entire application. Follow the concepts, principles of a layered architecture, specifically focusing on a canonical domain model, so we don't have different domain models for different use cases. And again, a big important part here, the composability is having this notion of an orchestration layer, things like web, batch, integration, etc. And then below, standard service repository infrastructure layers. Again, put your program model, program interfaces, make sure your framework's not forcing you to implement certain types, extend certain classes, catch certain exceptions. Those are all the kinds of things that will make your life difficult as a programmer, and also make it difficult to reuse your components in different ways. So following that, separation of concerns, we don't want to have our transaction management, security management, or our XML marshalling code all mixed together in our service layer. We really want our service methods to be really small and focused on the business logic, because in the end, we're probably getting paid more for the concrete business logic. As I mentioned before, when possible, externalize all your configuration, external properties files, Spring supports these kinds of things, as well as environment-specific configuration. Maybe some of you have heard of the environment support, so environment-specific bean configuration and profiles in Spring in recent years. So we started a little bit late. I think we have a few more minutes. How long do we want to go to? Are people interested in hearing a bit about the roadmap for 4.0? Yeah. Okay. Okay, so a few quick slides here, just kind of a tasting. And 4.1 is almost out. I haven't checked my emails lately. For an M1, sorry, 4.0 M1, first milestone. We've already done some of the work there. Going in order, so first class support for Java 8 based applications. We're actually already building against some of the early access releases for Java 8. In case you want to check out the current master branch from GitHub for Spring, we are actually compiling against Java 8. I think build 88 because build 89 doesn't work, so it's rather in flux at the moment, but we're working on that. But we'll be looking at stuff like some of the new language features, like lambda expressions, right? Things like closures, we're familiar with that. Allowing for callbacks with templates. So in Spring, we have the heavy usage of the template design pattern with callbacks to things like JVC template, JMS template, things like that. And with lambda expressions, you'll be able to write really concise, just much more concise code without having to have those kind of annoying anonymous inner classes. Also, other support things like current execution, fork join, MapReduce, etc. Lots of cool stuff is happening there in the Java 8 world. In terms of date and time, so we already have support for standard Java util date, etc. We also have support for Jota time within Core Spring. We'll be adding support for, or have started adding support for JSR 3.10, so the new date and time APIs for Java. Next up, Groovy. So Groovy 2 and configuring Spring with Groovy 2. Basically, want to allow Groovy-based bean definitions and also allow Groovy as the language of choice for the entire application. So in the past, you might be using Groovy within your application, but then using XML to configure, maybe Java config to configure, and now we want to be able to use Groovy throughout the application, so not just for application code, but also for the Spring configuration. And Groovy 2.0's static compilation basically supports the complete picture here, making this possible. In terms of new Java EE Enterprise APIs, so Java EE 7, basically we're providing support for upgrades to existing APIs, so JMS 2.0, JFK 2.1, bean validation, 1.1 if you're familiar with hibernate validation and annotations, etc., so declarative validation. Servlet 3.1 and fully covering JCache 1.0, so kind of alongside our existing caching support with things like add cacheable in Spring. New is WebSocket support. So if you've been following local recent commits, Ross Stoyanchez has started a heavy work on support for WebSocket style architectures in Spring, providing support for JSR 356 and also related technologies where possible. So basically looking at different types of deployments for web-based applications with WebSockets as opposed to deploying just in Jetty or Tomcat. Something also new here, so fine-grained eventing and messaging, building on the event model already existing in Spring, but introducing fine-grained eventing and messaging within the application, aligning with the functionality we have in place for the JMS message listener container mechanism, which I mentioned earlier as well. In terms of getting rid of the old stuff, we've already done this. A lot of this has been done in the M1 release. So pruning and dependency upgrades. Basically, this is 4.0, so it's a new major version, and then we've taken this opportunity to delete a lot of deprecated APIs and deprecated class hierarchies that have been existing in the code base for a while. So if you're using things like the old class hierarchy for Spring MVC, we've just completely deleted it. If you're using any of the old JUnit 3.8 support, we just completely deleted it. So when you upgrade to 4.0, stuff might not compile, might not run. Basically what we're saying here is, sorry, the best way forward is to see what's deprecated in Spring 3.2 up through 3.2.2. And if something's deprecated there, when you move to 4.0, you might get some surprises. So try to get rid of your deprecation warnings for it. In other words, stop ignoring those deprecation warnings in your IDE, in NetBeans, Eclipse, etc. And we're also raising the minimum dependencies to Java 6, so Java SE 6 and Java EE 6, with some compromises for EE 5 service and higher. So, in closing, just a few resources here. Hopefully you're familiar with them. As I mentioned before, Spring is not just a Spring framework, it's also an ecosystem, so several different projects. And you can find those at this URL with links to the reference manuals and Java doc. Spring forums, if you have questions, want to interact with other developers, ask questions directly, go straight to the forums. Another thing that's very popular these days is Stack Overflow. So you'll find a lot of information on Stack Overflow, a lot of talented, informed developers answering questions there. If you find a bug, or if you have a feature request, or if you want to suggest some way to improve something, go to Spring Jira. Also in Spring Jira, we have a relatively new fixed version. So basically, asking for contributions. So if you want to go there and check out how could I contribute, which issues are there that the Spring team doesn't currently have time to develop, that I could maybe take on as a workable or relatively small chunk of work for myself, you can check that out. And the GitHub repository is all the source code is there at github.com/Spring Source. So premature clapping, something that, anyway, so blogs, my company has a blog. I blog typically about the testing work, or the work that I do in the testing support in Spring. Also, of course, Spring Source itself has a team blog, and I blog there about once a year as well, but the other team members blog there quite frequently, so that's a great source of information. And if you want to follow me on Twitter or check out some of my other presentations on SlideShare, here's the information. And I think that's it for the time.
Now, there were efforts to move to different logging, I think, so.
Yes.
How about that? So something like.
As far as I know, and it's not currently something we're talking about. I mean, it was something that we were talking about, switching from Apache Commons logging.
Yeah.
Thing is, well, I want to speak for everyone, but from my perspective, it's a lot of work with not that much win, and there are ways to actually achieve it. So there's, I think Dave Science and other people have basically documented how you can use other logging frameworks in place via particular bridges. So there are ways to get it working without changes to Spring.
Okay, so let's wait for it. And the second question, there were initiative to move from CJLib to ASM?
To Java system.
Yeah.
From CJLib to Java system. So in 3.2, we inlined both ASM and CJLib.
Yeah.
So those are nice features. So in the past, you had to depend on those and make sure that the rest of your code base could work with those versions, well, at least for the CJLib version. And then in 3.2, we inlined, so using jar, if you're familiar with jar, it's basically a framework that allows you to take an existing jar and take it apart and move all the packages to different packages in your own package space. We've done that in Core Spring for ASM and CJLib. And the point is we're staying with that at the moment for Java 7 and Java 8 compatibility, bytecode compatibility. So at the moment we're not looking directly at the Java system. It's still on the radar, but not a primary focus. Anything else? Okay, so we have a break. Yeah.